2.6. It's called Piecewise Functions. And what it is, it's more than one function pieced together from a domain. So for this first one, we have the function x minus 2 if x is less than negative 1. But then once you get where x is greater than negative 1, it's going to be the function x plus 3. So the easiest way, well, I'm going to show you two different ways to do this. Just graph this whole function, x minus 2. So that means the m is 1, the b is negative 2. So I will go where the b, the y-intercept, is negative 2, and I'm going to put my point. My slope is 1, rise 1, run 1. Rise 1, run 1. And I'm going to go the other way. Down 1, left 1. And I got to keep that positive slope. So then I'm going to draw my graph. And this is that function x minus 2. Well, I need to have this function x plus 3. So my m is 1. My b, my y-intercept, is positive 3. Well, that's going to be here. Positive 3. Rise 1, run 1. Down 1, left 1. And I'm going to have my slope. And I'm going to draw my line. So what this means is I want the function x minus 2, this red one, when x is less than negative 1. So where is x negative 1 on that graph? I'm going to go here, and I only want this function where x is less than that negative 1. So I'm going to erase all of this part. Now it's going to erase some of the graph on mine, and I want this to be an open circle here because it's not equal to, I'm going to have an open circle. And then when x is greater than negative 1, so I go up this y vertical line, negative 1. When x is greater than negative 1, I want this blue function. So I'm only going to have this part going to the right, and I'm going to erase this part. And for this one, I do want to have it filled in because that's where it is equal to. So this is that function where when x is less than negative 1, it's x minus 2. When x is greater than negative 1, it's x plus 3. Greater than or equal to negative 1, x plus 3. So for this one, we're given the graph of the piecewise function, and we need to write the function of this piecewise function. So I'm going to say f of x, and because there's 3 separate graphs, means that there's going to be 3 parts to this piecewise function. The first part is going to be this graph here, which is where x is less than positive 1. It's not less than or equal to because that's an open circle. So it's x is less than positive 1. This one's going to be where x, we'll go to that one in a little bit. Let's do just this one first. Okay, so let's write the equation for this one. And my slope and y-intercept, this is my y-intercept. So that's going to be b is equal to 3. And my slope is a positive slope. And I need to find another point right here. So it's going to be rise 1, 2, run 1. So that's going to be 2 over 1. And it's a positive. So that's 2x plus 3 when x is less than 1. And then this one is between, when x is between 1 and 2. So the way we write that is 1 is less than or equal to x less than or equal to 2. This means x between 1 and 2, and I put both the equal bars on this because the circles on the ends are filled in. And I can tell that my slope is 1, but notice that it's going in a negative direction. So my slope is negative 1. I'm going to be looking at this red one. Now, I can't tell the y-intercept, but just you keep using the slope until you can hit the y-axis. So if I keep using the slope, rise 1, left 1, and that keeps it in that line, that means my y-intercept is going to be at positive 2. So my function is going to be negative x plus 2 when x is between 1 and 2. And this last one, notice it's just a horizontal line. And we talked about the equation for horizontal line is going to be y equals a constant. So in this case, if I continue, y is going to cross the y-axis at 3. Notice every point on this line, y is equal to 3. So the y part is already here. You're just going to put 3 as the function, and this is where x is greater than, just greater than, not equal to, positive 2. So you have one function when x is less than 1, you have a different function between 1 and 2, and then you have a third function when x is greater than 2. Okay, so for this next one, I'm going to show you a different way that you can go about graphing it, but I'm also showing you one with 3. You can still graph this one the same way we did the last one. I just want to give you different ways, and whatever works for you is fine. So this way is a way where you find out where each part stops, basically, or where that open circle is or where that closed circle is. And you know where the x values are for each of them. Okay, so I'm going to start with this bottom one first, actually, and work our way up. So for this bottom one, the open circle or closed circle, in this case, it's going to be a closed circle because it has this equal bar on the sign, and that's going to be where x is equal to 2. So I know the point of where it's stopping has an x equal to 2. And anytime you know the x value of a function, you can always find the y value by plugging in the x. So I want to plug that 2 in here. And so I get negative 2 times 2 plus 3. Negative 2 times 2 is negative 4, plus 3 is negative 1. So that means the y value is going to be negative 1. So I have the point 2, negative 1. And in this case, it's going to be a closed circle, we said, because of the equal bar. And I want to do a slope of negative 2. Understand, I'm not always just going to go down if it's a negative. Okay, because if I wanted to go to the left, then I would go up 2 and left 1 to get a negative slope. But for this one, I do want to go to the right. So it is down 2, right 1, down 2, right 1. And so you find out where that point is, and then just use the slope from there in the correct direction, either to the right if it's greater than or to the left if it's less than. And I only want the portion going to the right. So I draw that line there, and this is the line negative 2x plus 3 if x is greater than or equal to 2. If I keep going in the other direction, up 2 over 1, up 2 over 1, you see the y-intercept would be 3, which it matches up. So to do this middle one, I need to find both endpoints, because this is going to be a line with 2 endpoints because I only want it where x is between negative 4 and 2. So to find both endpoints, I plug in both of those x values. I have one endpoint at negative 4, so that's going to be negative 4 minus 2 is negative 6. and I plug in 2, and I plug that in here. 2 minus 2 is 0. So I have the point 2, 0, and the point -4, -6, and I want to connect those two lines. So then I just connect those two endpoints to the line. Is that? And if you notice, my y-intercept is -2, my slope is 1, up 1 over 1, it's in a positive direction. But you can also find the endpoints and connect them. Now there is one more thing I haven't done here, is pay attention to the endpoints. Are they open or closed? And this one on the -4 should be closed. This one on the 2 should be open. So let me go close this one in, and that's it for that one. And then for this first one here, it's the line -3. And understand that this is a y, so you really have y equals -3, you really have y equals x minus 2, and y equals -2x plus 3. Okay, well the line y equals -3, which is the one we're doing, is a horizontal line where y is equal to -3. So go find where y is equal to -3. That's here. If I was drawing the whole graph, it would be all the way over here. Well, I only want where x is -4, so that point that you're starting off is when x is -4 and y is -3. So -4, -3, and I want where x is less than, so it's going to be going to the left. And this is the graph of the piecewise function. F of x is -3. If x is less than -4, between where x is -4 and +2, I have the line x equals 2. And when x is greater than 2, I have the line y equals -2x plus 3. So here we're going to graph an absolute value function. What an absolute value function is, it is a piecewise function. Okay, so it's going to be f of x is equal to x when if x is greater than 1, or sorry, greater than 0 when it's positive. But it's going to be the line f of x is equal to -x if x is less than 0. And this will have an equal bar on it. So what happens is, say I have a table of values, -2, -1, 0, 1, and 2. When I plug in -2, that becomes +2. When I plug in -1, that becomes +1. When I plug in 0, that's 0. Plug in 1, that's 1. Plug in 2, that's 2. So what happens is I have this point, 1, 1, 1, 2. But when I go to the other side, -1, the y value is +1, -2, +2. So I have a negative slope going this way, and then it hits this vertex here and turns around, and it's the positive slope going the other way. And for right now, you just need to know what it looks like. We're going to graph it later. So this is the parent function that we'll get into in the next section. And you can remember what the absolute value function looks like is because it's absolute value and it looks like a V. Okay, the shape of the graph is a V, but it's really two different linears. It's one with a negative slope, one with a positive slope. Okay, here's some U-try problems. Go ahead and try these on your own. Graph the first one. Write the function for the second one. There's 3 different parts to it. And notice that each unit here is 2. So when it's at the half, you can use it from the half. That's a unit of 1. So like right here, this is x is -1 to when x is +3. Okay, so when you're finding the slope of these lines, you may have to use up to a half, like this is -3 right here at that point. Now in our football season, I'm going to give you a football joke. Why don't eggs make good quarterbacks? Because they're too quick to scramble.